2018 Exam 2 Core Data Analysis Question 3. Interesting one here. They're going to say use the data in Table 3, this is Table 3 up here, to complete the time series plot for Melbourne. Melbourne is this dotted line. I hope they weren't expecting students to actually do a dotted line, but there you go. Now we've got up to this point. So 2012, we can see it finishes here at 28 because we're doing Melbourne. So let's just highlight we're doing Melbourne here. So we've got to do 2013 is also 28 right there. So we can draw the line going across there. It's 28 again. Then it's 29. And then it's, you might want to use a ruler on this, and then it suddenly shoots up to 33. That's quite hard to rule right across, but I think it looks a bit like that. So 28, use a ruler. I didn't. Look how messy it looks. There you go. But 1 mark. 88% of people got that right. All right, here comes the rain again, falling on my head like a memory. Now we've got this equation for Sydney, and we've got to draw this onto the time series plot on page 8, which is actually just to our left. And all you got to do basically is take your endpoints and put them into that equation, and you'll get the coordinates. So if you do minus 2280 plus 1.15 times 2008, you should get 29.2, which looks like being about there. And you do exactly the same thing again. But this time you do 2016 at the other end, and you get 38.4, which is about there. And an interesting point here is that it said those who answer correctly typically used a ruler. I can't actually use a ruler very well on these touchscreens. It tends to freak it out. Look how good that was, though. That got me the mark. Totally did. All right, and that's all you had to do. But ridiculously, only a third of students, a half of students got that right. That's not very high, is it? Now the next one is use the equation, right, that we've already got, and determine the average rate of increase in percentage. What they're trying to do here is just ask you about a gradient. There's always a gradient question or a y-intercept question. So you should have that sense of, oh, it's either going to be gradient or y-intercept. And well, the gradient is 1.15, which means it's going by 1.15%. A common mistake was to think about this as being a sort of a financial question and saying that it was 15%. The gradient here is just 1.15. Think about it, it's not going up by 15%. Look at your graph. It didn't go from 29 to 44, did it? That would be an increase of 15%. Okay. Next one says, use the least squares line to predict the percentage congestion when the level in Sydney is 43%. So, congestion level is 43. So, what we have to do here is we say 43 equals minus 2280 plus 1.15 times year. Right? That if you're not comfortable with the calculator and a bit of algebra, you might want to use the solve function on that. So you might want to grab your calculator and go solve for y like that. Now, if you do all that, or you can play around with the algebra, you should get 2020. So the year, because we're trying to predict when, is 2020 when you solve that equation. There you go. Okay, so now we've got this least squares line to model the trend in the data for Melbourne, and they've given us that data again here, and they're given the intercept of this line is this, and it says round this to 4 significant figures. 4 significant figures, so it's minus 1, 5, 1, 5, because 1, 5, 1, 4, that's 4 significant figures, but we draw our line and we look over here and we ignore the rest of this bit and we say the 7 means the 4 goes up to 5. So it's a bit like rounding. Most people got that wrong because they went for 4 decimal places. Oh dear, embarrassing. Now, interestingly enough, in the next question, we need to actually put that value in, and it just goes straight in here, minus 1515, because it does actually say we're going to round to 4 significant figures. So we've already got the y-intercept, and now we just need to find the slope of that. Now the best way to do that is to start hitting the calculator on this. So we take all that Melbourne data. Let me just delete all this. So that Melbourne data, what's that Melbourne data? This stuff. I'm going to put that into my calculator. I've got my year. That's going to be list 1, list 2 kind of situation. And there it is. List 1, list 2. Then I go calc, regression, linear reg. We're familiar with this by now. List 1 is X, list 2 is Y. Good, just double checking all that. And there's my values. Now, what I love about this is we've got that. That is that. And you can see I'm actually set to Y equals A plus BX. So again, they love to do Y equals A plus BX. That's their preferred format on the exam. So just get used to that. And then there's our B value. So we've got to do it to 4 significant figures. So this first 0, not a significant figure. It's just a placeholder. And then we got our decimal point, and we go 7, 6. It's 2 significant figures so far. 6, 7. And that's all we need to do. Now, I think they're being a bit fussy in answering this, but apparently only 2% got the full marks on this. So remember, you've got to quote the values of appropriate statistics. So if you actually remember from your data, in the 2008, Sydney started at 29.2, which is greater than the 24.5 of Melbourne. And also the gradients are different. Of Sydney, we said that was 1.15, which is greater than the 0.77 of Melbourne. Remember, we've worked all those things out. So you're starting higher for Sydney, because that's your intercept. That's the y-intercept. And the gradient is steeper, or gradient is higher. So because you're starting at a point and you're going to keep going higher, there's no way that Melbourne can ever beat Sydney. Sad.